Hi, everybody, and welcome to our first lesson on C programming. First, I just want to say that I hope everybody is doing okay, that everybody's safe and healthy, that your families are safe and healthy. I know we're all making a lot of difficult adjustments, changes to work, not going out, not going to school. There's a lot that we're dealing with, and hopefully everyone is doing the best that you can. This teaching online thing has certainly been a difficult adjustment for me. I really wanted to find some kind of a whiteboard that I could use so that it would be like our normal class. Well, you can see that I'm ending up using PowerPoint. And you know I don't use PowerPoint. I don't like PowerPoint. I could be wrong, but I don't think you like PowerPoint either. So if I can find something that's workable, I may switch, or we might be using PowerPoint for a while. A couple of things I want to mention before we get started. I put up some instructions on how to get set up using NetBeans and how to get set up using Eclipse for C programming. I found out after a lot of trial and error that actually Eclipse, C programming in Eclipse has a bug in Windows, so you can't use it. I mean, you can, but it's not worth it. It has some difficulties that are not worth it. So it works fine on a Mac. I had a friend test it for me, but it's a no-go on Windows. Okay, another comment is I found an online document called C for Java Programmers. It's somewhat brief, but it's good. I don't want you to have to go through all of the things that you already know from Java that are the same in C. So we'll be using that as kind of like a textbook for this section. Okay. I put up a module for us for our C programming, and I put a link to this textbook in there, and I also put in a page that lists the sections that I want you to read to start out with. I'm asking you to skip the section on development and execution. You can read that if you want, and you can actually follow it if you want. It discusses how to do C programming from the command line. So in Windows, that would be using a command prompt. It's the DOS window, what we used to call it. On a Mac, you can do that with the terminal window. But if you don't want to embark on that adventure, then just skip that section and stick with the development environment that you already installed. Java is a descendant of C, which means that there are a lot of things that are similar in the two languages. But there are a lot of differences also. And I guess I would say there are two major differences. One is in the intent of the language, and one is in the features of the language. So in the intent of the language, C was developed to replace a lot of assembler coding, and it has done that very successfully. So in the past, when you needed something to be fast or small or both, then you wrote it in an assembler. And much of that type of code is now written in C. So that was the intent of C. The intent of Java is different, and that leads to the other difference between the two, which is Java being object-oriented. So C is a procedural language. So you can see on this slide, and you'll see also on the next slide, I listed some of the differences between the two languages, and some of them have to do with the fact, the first item, Java has classes and objects, C does not. So that's a big difference, and you will see that it will take a bit of getting used to. A Java program is made up of a set of classes and objects. A C program is made up of a set of functions. In Java, we have rules about file naming. So every public class must be put into a file with the same name as the class. In C, there are no rules about file naming. Any function can go in any file. You can have one file with 100 functions in it if you want, or you can split your functions up into separate files. And generally, developers will partition their code into components, and the functions that are part of a certain component are put together in one file. And those components might be similar to the functionality of classes in a Java program. So you could think about it that way, that all the stuff dealing with my stack is going to be in one file, or all of the functions that do some kind of user interface processing are going to be in another file. But it's totally up to the developer. Arrays have some similarities and some differences. So the basic syntax of using arrays are the same with our square brackets, and the first element is always has subscript 0. But in Java, arrays are objects, and the array has a length field, so you can always check how long is your array. And the array bounds are checked at runtime. So if your subscript gets out of bounds, you get an exception. In C, arrays are not objects. There's no bounds checking at runtime. So if your subscript gets out of bounds and goes too far, that's going to result in some kind of unpredictable error. There's no way to check that unless you have a separate variable or you've hard-coded the size of the array, because the array itself does not have any size information. There's no way to tell how big the array is just from the array variable itself. Strings are also different because in Java, strings are objects. In C, strings are arrays of characters, just like what we have in MIPS. And in C, we do have some built-in library functions to help us manipulate strings. We don't have to write all the code from scratch, but we are working with arrays and not with objects. Java has exceptions. C does not have exceptions. Java has a built-in set of collection classes, stacks and queues, lists, hash tables. C does not have any built-in collections. Java has generics. C has no generics. Okay, here are some more differences between Java and C. In Java, we have the Boolean type, which can take on the values of true and false. In C, we don't have a Boolean type. So instead we use int. Well, I have to qualify that a little bit. Some of the newer versions of C do have a Boolean type, but the older versions did not have it, and many C programmers don't use it. So as I said in the one of the earlier screencasts that I did, we're going to stick with an older version of C so that what we learn will help us even if we're looking at C code that was written in an older version. So in the older versions, no Boolean, and there's no such thing as true and false. Instead, you use an int, and 0 stands for false, and any other value stands for true. So that's different. The input and output functions are different. So we'll have to learn some new input and output functions. And the input and output functions for C can be a little, not sure what's the right word to use. They're not as smooth. There are some quirks, and that's what it's like when you're programming in C. So that's one of the first things we're going to talk about is basic input and output for the keyboard and screen. Okay, in Java we have that wonderfully convenient string concatenation operator, the plus sign. We don't have anything like that in C. There is a library function to concatenate strings. So you can call a function to concatenate, but you don't have that nice convenient plus sign. In Java, we have references. In C, we have pointers. Pointers are like references, variables that contain the address of some other variable. But pointers in C can do a lot more than references in Java, so we'll be spending some time on that. In Java, we use import when we want to abbreviate the name of a class from another package. In C, we don't have import. We have #include. It's not the same as import, but it kind of gives you the same feeling before you know what it's for. And that kind of goes along with the next thing, which is that in C we use function prototypes, and in Java we don't need them. So just like variables, functions need to be declared before they're used so that the compiler can check, did you call this function correctly? Did you use the right number and type of parameters? In Java, that can all be checked because the compiler knows, based on the file naming convention, it knows where to look to find the function, and then it can check if you're calling it correctly. In C, since any function can be in any file, we have to help the compiler with some information so that it can do that checking. And that's the purpose of function prototypes. And the include statement is used to help us get the function prototypes that we need. Both Java and C use call by value, so that's the same, but the pointers in C can be used to create call by reference. And call by reference is what we have in Java when we pass a reference. The reference itself is passed by value, but the object it's pointing to can be modified inside the called function. We can do that in C manually by creating reference parameters with pointers. In Java, we have a huge set of APIs, built-in classes of all different types, our collections for interacting with databases, for networking, user interface development, all kinds of things. In C, we have a bunch of library functions that are available for us to call. So it's similar, but not nearly as robust as what we have in Java. So those are the main differences between Java and C. I'm sure I left something out, but those are the main ones that we're going to notice. However, there are a lot of things that are the same between Java and C, since Java was based on C and then had many things changed and added. So our variable types are the same. The basic variable types, primitive types in Java, character, integer, char, int, float, and double. There are also more short, unsigned int. We're not going to worry about those very much. In fact, we probably won't use them at all, but there are a bunch of others. How we declare variables and how we initialize them is the same if you remember that we don't have any objects. So everything that we declare and initialize is going to be in the same style that we use for primitive types in Java. Arrays are declared differently because they are not objects. So we will see that probably in our next lesson. But on your basic scalar variables, the declaration and initialization is the same. Arithmetic and logical expressions are the same. So the operators that we use for comparison, for and or, for multiplication, basic arithmetic, the assignment operators such as plus equals, and the increment operators and decrement operators, plus plus and minus minus. Those are all the same. Our control statements and the syntax of those statements is the same. If, for loops, while loops, do while loops, and switch, all of those are the same, and they use braces the same way. So if we want more than one statement to be controlled by one of these control statements, we put them inside braces. One thing that we don't have in C is the enhanced for in Java, which uses the colon to loop through a collection. We don't have that in C. And the basics of functions and parameters are also the same. The syntax for our function calls and function headers, and the syntax for parameters. Those are the same. Let's talk about how we print on the screen, printing on the display. We're going to use the printf function. This is the same as the Java printf, but there's no system.out that's part of the printf. It's just the printf function by itself, and anytime you use printf, it will automatically print on the display. There's no need to add anything to it to tell it that you want it to print on the screen. So for example, the classic hello world, we just put the hello world inside of our string. Double quotes makes a string literal. Printf is not like print line. There's no automatic inclusion of a new line. So if you want a new line, if you want to print a new line, you have to explicitly include that in the string that you're printing. So in this printf example, we have only one parameter, which is the string we want to print. But we can have additional parameters when we want to print variables. In that case, the first parameter is the format string, and the rest of the parameters are the variables that we want to print. As I said, if you want a new line, you have to include it in the format string. Now, to add variables to your printf, you have to include a placeholder in the format string for each variable. And the placeholder says what type of variable you want to print and where in the string do you want to print it. The location of the placeholder within the format string is going to determine where the value of the variable prints in relation to the other items in the format string. You may have used printf already in Java. It's a very nice way to format precisely your output. So here are the basic placeholders. So when you want to print a variable, you add into the format string one of these placeholders that says I'm going to print. %d means I want to print an int. %f says I want to print a float or a double. %s says I want to print a string. And %c says I want to print a char variable. And remember, that's a single character. Here's a sample printf statement. So the format string says you entered, then the %d says the value of the first variable will be printed, then the word and will be printed, and the second %d says the value of the second variable will be printed, and then it will print a new line. So it will print you entered, and then it will print the value of num1, then the word and, then the value of num2, and then a new line. The number and types of the placeholders must match the variables being printed. So since I have two variables there, I need two placeholders. And since I put in two placeholders for ints, num1 and num2 need to be int variables. There are many options to control justification, the length, the number of spaces used for printing the value, the number of decimal places, and so on. The only ones I'm going to talk about right now are when you want to print a float or a double. You use two numbers, L.P, in front of the F. So L is the total length, the total number of positions you want to use for printing this number. That includes everything. The whole number part, the decimal point, and the fractional digits. And then P is the number of digits after the decimal point. So you're going to print L. You're going to use L spaces to print, and the value is going to be printed with P decimal places. So here's an example where we create a float variable called temp and initialize it to 54.377. And then we have a printf statement. And so we use %5.2f. So that means a total of 5 characters will be used to print. 2 of them will come after the decimal place. 1 will be the decimal point itself. And that leaves 2 left for the positions to the left of the decimal point. So in our case, it will print the temperature is 54.38. If the field is larger than the value being printed, the value will be right aligned within the print area. So if we had printed it with 8.2 instead of 5.2, it would have had 3 blanks and then 54.38 for a total of 8 spaces. And as you can see in this example, If necessary, the value will be rounded off, or it will be padded with trailing zeros if necessary to fill in the appropriate, the requested number of decimal places. And here we have another example. And in this example, here is a more complete example. And in fact, it's a complete program. So let me make a couple of comments about that. So we have the include statement for standard.io.h. That is required anytime we're going to use any IO functions. So that's always going to be there. And as I said, we'll talk more about includes sometime soon. Then we have our main function. In C, main usually returns an int. In Java, main is void. So you might wonder what that means, that main would return a value. And it's actually used when a program is part of a larger system. The return value from main is used as an indicator of whether this program in its entirety worked or not. So usually a value of 0, return 0, means it was all good, and a value that's not 0 might indicate some specific error, but that depends on the specific program that was written. So int main is common. You'll notice we didn't return anything, and Java won't allow you to do that, but C is a little less careful with things like that. Also, main has its parameter list, which I talked about before. The meaning of this parameter list is the same thing as the meaning of the parameter list in main. In Java, it says I'm going to pass an array of strings. The first parameter says how many strings are in the array, and the second parameter represents the array of strings using pointer notation. So don't worry about that right now. I know it can be frustrating to have someone show you something and then say, don't worry about it. So I apologize for that, but we will get to that later. Okay, so inside main, I declare two variables and I print them. So we have an int and a float, and you can see in one printf statement, I used two format codes, one for the int, %d. That means that the first variable that I have to list after the format string should be an int. And then some more characters print, and then we come to the code for the float. So that means that the second variable that I pass after the format string should be a float. And on the next slide, we will see the output. And here is the output. And if you look back at the previous slide, you will see that we have the format string, and wherever we had a placeholder, it has substituted the value of the variable that was passed as a parameter. So %d, it prints the value of num. And for the float, since we use 8.4, so we have 4 after the decimal point, 1 for the decimal point, 1 for the 3, that's 6 characters. And so we have 2 leading blanks to fill up the full 8 characters that we requested. You can find all the details about this, maybe more than you ever wanted to know, at the following link on the Wikipedia page for the printf format string. Okay, how do we read from the keyboard? In C, we're going to use the scanf function. Scanf automatically goes to the keyboard and waits for you to enter a value. Scanf also uses a format string, which has to contain a placeholder for the type of variable that you want to read. And then you have to give it a variable, which is where you're going to store the input value. So when the scanf is executed, execution will pause, and when you type something at the keyboard and hit enter, the value that was entered will be put into the variable that you listed in your scanf statement. You can put other things into the format string, but I don't recommend it because then it requires that your input match up with the rest of the format string. So the best thing to do is just to read one variable in one scanf and don't put anything else in there. So here's a simple example like this that shows how to read an int. So if we have a variable num, we prompt for an int, and then in the scanf, it looks almost like the printf. Scanf, the format string with the %d, and then the variable. However, the variable has to be preceded by an ampersand. We will talk about ampersands, but the ampersand operator in C means address of. So you can think of the scanf as saying, I want to read an int, and this is the address at which I want you to put the value that you read. So instead of giving the name of the variable in which to put the value, we give the address of the variable in which to put the value. If you don't want to think about that right now, if you find that confusing, then just remember that in scanf, you always must put an ampersand in front of the variable name that you're reading. So as I said in the last slide, just to emphasize, the ampersand is required before the variable name in the scanf, not in the printf, just in the scanf. So here's an example of how we would read a float. It's very similar. We use %f instead of %d. %f, I want to read a float. We give the name of the variable we want to read into, and we precede that variable name with an ampersand. And as I said before, but just to emphasize it, it's better not to do multiple reads in one scanf. It's better to read each variable separately. So in summary, what we discussed today were the differences between Java and C, and then what things are not different, what things are the same, which turned out to be a lot. So a lot of things are different and a lot of things are the same. The main thing to remember is no objects. No objects. And then we discussed how to print on the screen and how to read from the keyboard. And you will find some practice exercises that use I/O and also some of the basic control structures and variables that are the same as what you've always used. All right, I will be back with something else for you later this week.